Hello, everybody. I restart my state another connecting session. So today I solve this question: reorder list. So you were given the head of the singular linked list. The list can be represented as like this. Reorder the list to be on the following form: L0, Ln, L1, Ln. I see. The Ln minus 1, 2, n minus 2. You may not modify the values in the list nodes. Only nodes themselves may be changed. I see. Okay. So let me clarify my understanding first on this question. So as the interface, I'm given the root of the node. I mean, root of the, let's just say head of the linked list, and I will return. I don't return anything. Modify head in place in order. And as a side effect, nodes are sorted. Yeah. Okay. So the only thing I'm wondering is if there is at least one element in the linked list or not. I check it, and yes. So head is not null. Yeah. So there is at least one node in the linked list. Okay, so let me take a look at examples. So if the given list looks like this, then I should modify it to 1, 4, then 2, and 3. Okay, good. Yeah. So as the brute force approach, I think I can use create a list of nodes in the given order, like 1, 2, 3, 4. Yeah. Then I use 2 pointers. So yeah, index 1, maybe I should say left and right moves from here. And until they reach, until they encounter, I guess the left node and connect it to the return linked list. And then I do the same for right node. And also I move left pointer and right pointer after connecting the node to the tail of the return list. Oh, here I build a new array, new list, and head should point to the new list, like this. For this approach, the time complexity should be O of n, because creating the list of nodes takes O of n time, assuming that there are n nodes in the given linked list, and these 2 pointers. In total, 2 pointers should move n steps. Yeah, so in total it should be O of n time. For space complexity, it should be O of n because I need the list for the nodes. Okay. So I'm thinking if I can optimize this. What I've noticed is for the time complexity, I think this can't be optimized anymore because I have to update the node.next for each node. Yeah. So time complexity should be O of n. This is best achievable time complexity. For space, maybe I can optimize this. Mm. The biggest problem here is I'd like to move the, yeah, if I try to use the 2 pointers, on the linked list, I cannot move back. Yeah. I can move the left pointer, but the right pointer cannot go back. Hmm. Okay. Give me 1 minute to think if I can achieve it in the constant space complexity. So left pointer here, right pointer here. Left should come here next. Right should come here next. Hmm. Or maybe hmm. Okay, let me think. If this is 1, 3, 4, 5, 6, 7, in this case 1, 7, 2, 6. So 6 and 7. No, I don't come up. So yep, let me go with this approach. Okay. Here I create the nodes list. Okay, here I get the nodes list, and then here I do the 2 pointers. So firstly I move the left pointer, and then I move the right pointer. So maybe I can have the frog here, move left is true. Move left here. Otherwise, move right here. So I do something and then move the left pointer in the end. Or move the right pointer in the end. Then reverse the frog in the end. Okay, the remaining part is how I can connect the new current node to the return linked list. So return linked list looks like this. The current node next should be nodes left this node. Then move the current. Samely, oh no, should do it first. When I move the right pointer, current next is node.right, then current is current next, and then right pointer is moved. Okay, good. The last thing I have to do is to implement the helper method. So here, oh, and I return, sorry, in the main method, I return read.next because the first node is a pseudo head. Here, yeah, this is it. So yeah, the last thing I have to do is before appending this current to read, I have to, clear the next pointer. So let me call it temp. Or I should say next node. Yep. So this is how it works. Next node, this is a kind of temp variable. Then current.next, I clear it, and then after clearing, I append it to the return list here. Then, yeah, I move the current pointer. Okay, good. So let me walk through my code. I trust that the helper method is correct. That being said, I focus on the dry run of the main method. So let's say I'm given something. Okay. So let me start with a very simple case like this. In this case, nodes should be this one only. Then left pointer is pointing to 0. Right pointer is also 0. So now left, yep, in line 61, this is true. And read is something like this. Then in line 64, this is true. So I go to line 65. Entry is move left. Yes. So current.next is nodes at left. So this point to node 1. Then current is current.next. Yes. Then right. Oh, where was I seeing? So I should be in line 68. Left plus equal 1. So now right pointer is here. And then I go to line 74. Move left is flipped. So this becomes false now. And then I... Oh, no. I have to do it here. Yep. Then in line, I come back to line 64. But left is now larger than right. So I go out of the while loop and go to line 75 and return read.next, which is one node. I actually don't have to return it. So this is it. Okay. So I'm pretty sure that the... Wait. The first node is not updated already, so it's okay. Yeah, head is always pointing to the first node, which is 1. Good. Okay, so I passed this test case. Maybe I can check a few more cases, something like this. But to save my time, I will be for real quick. So let's say left, I create the node in this way, and left and right are here and here. So I focus on the logic in line 71 to 79. So firstly, move left is true, yes. And read is something like this. And now, firstly, this one is taken, and it becomes like this. And then current is current.next, and the left is incremented by 1. Good. Then I take a look at the line 84 and move left becomes false. Yep. Then I go to line 80 and current.next is move node.right. Nodes at index right. It should be 3. Yep. Then in line 81, current is current.next. So it goes like this. And right is decremented. So like this. Yep. And move left is flipped to true. Yeah. I think so far it's good. I'm pretty sure what happens next. So move left is true. So I go to line 76. And 2 is connected here. And then current is current.next. Goes like this. Then left pointer is incremented. So it goes here. And it goes to line 84. And move left is flipped. But it doesn't matter. And that's it. Okay. Again, this is as expected. I can find this index 132 order. I mean, which is 0 to 1 order in 0 index. So I'm pretty sure this is good. Okay, so that being said, I passed this test case too. Okay, so now I'm pretty confident in my code, so let me submit. So this is typo. Good. Okay, accepted. Great. Okay, so let me quickly wrap up. So today, I saw the question, reorder list. So in this question, I'm giving a linked list, head of the linked list, and my task is to reorder the list. Maybe I should say, yep, ordered instead of sorted. Okay, so my task is to reorder the list so that the index should be, nodes are sorted, ordered, like the original index should be positioned in this order, like 0 and 1 and -1. Yeah, like kind of zigzag. Yeah. So in this question, I firstly created the list of the nodes. Then I used the 2 pointers on that list so that I can take the node in zigzag order and created the new list. Yeah, I actually didn't create the list, but node 1, which should be the head of the original linked list, and also the head of the returned linked list. Sorry, nothing to be returned. So I should say this node 1 is always the head originally and after the reorder. So yeah, I updated the connections of the nodes from this node, original head, by taking the nodes with 2 pointers approach. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.